So we have differential equation dy over dx equals 2y minus 4x. And the first question is about slope field. Slope field is the way to approximate the solution of differential equation. So, but so far we've learned to solve the differential equation by solving the differential equation itself, and that is exact solution. And as approximation, we've learned about the Euler method and also slope field. So slope field also a good way to understand the shape of, like approximate the shape of the graph. So now we have here. So this is the slope field, and we have two conditions. The first one going through 0, 1, and the second one is 0, negative 1. If this passes 0, 1, backward and forward, both of them has the same slope. This is, it seems it has this linear function. Yeah, as we follow the pattern. And 0, negative 1, from here, it seems going down on the right side, getting like more stiff, and left side is more, a little bit more flat. Number B. Differential equation with initial condition 0, 1. So yeah, we approximate the graph already. It looked like a linear graph. Euler's method from 0 to 0, 2, and step size is 0, 1. So when x equals 0, y equals 1. So we will go through, like we will go further 2 steps. And the first one, y equals, the slope comes from this differential equation dy over dx 2y minus 4x. So 2y minus 4x, so the slope, let me write the slope here just to make sure. So slope was 2. So 2, 0, 1 plus previous y1. So this is 1, 2. And the slope becomes a 2, 4 minus 0, 4, so 2. So y becomes 2, 0, 1 plus 1, 2. So 1, 4. This is the approximate value. So the answer is f 0, 2 approximate to 1, 4. And number C, find the value of b. We already know the initial condition 0, 1, so 1 is 2, 0 plus b, therefore b is 1. So y equals 2x plus 1 is the solution for this, the differential equation, but it asks us to just justify or verify. This kind of thing is just to see whether this solution makes the equation true or not. So we can check this solution, the equation. So left-hand side means left of this equal sign. So left-hand side is dy over dx. And so at this moment we have y 2x plus 1, so this is 2. Right-hand side is 2y minus 4x becomes 2. So, this makes this true. Therefore, y equals 2x plus 1 is the solution for the given differential equation. Number D. This differential equation 0, 0 from here, and it has local extrema. If so, local maximum or minimum, justify your answer. Yeah, it seems if it has local maxima through this slope field, so we can say 0, 0. Oh, yep. 0, 0 becomes 2, 0 minus 4, 0, which is 0. And the dy over dx when how can I say? So on the left side seems positive. Dy over dx on the right side is negative. So according to the first derivative test, by the first derivative test, as the first derivative test, dy over dx equals 0 at 0, 0, and it changes sign when it passes 0, 0 from positive to negative. Therefore, y has its maximum at 0, 0. This is the first method. And maybe second method. We can use the second derivative test too. Since we have this one, dy over dx, we can make second derivative 2y minus 4. But now we know dy over dx is 0. So this is negative 4, which is less than 0. Therefore, by the second derivative test, dy over dx is 0 and dy second derivative is smaller than 0 at 0, 0. Y has its maximum at 0, 0. Number 10. Differential equation dy over dx equals 2x minus y. Slope field. Okay, when y equals 0, this is 0, negative 2, and 2, and 4, and 3, this is 2, yeah, 2, 3, 4. This is just to understand. And this also one smaller, so negative 1, negative 2. This was 2, 1, 0. And negative 2, negative 3, negative 4. So this is the slope field. And sketch the solution. Pass it through 0, 1, so this seems decreasing. So we can make decrease, and some moment it turns to increase. So the solution has local minimum at ln 3 over 2. Local minimum means, because this is a different, it seems differentiable function. So the local minimum happens when dy over dx equals 0. So dy over dx equals 0 at x equals ln 3 over 2. So 2x is y, minus y should be 0. Therefore, y is 2 ln 3 over 2. And number C, given differential equation is, let me write it down, 2x minus y. So initial condition 0, 1, and we want to go to negative 0, 4. So x, y, let me find the slope too. 0, 1, negative 0, 2, negative 0, 4. So the first slope was negative 1. So y negative 0, 2 is the step length. Step length is 0, 2, but it's decreasing, so we need to make it negative 0, 2 plus 1. So this is 1, 2. And the slope is 2x negative 0, 4 minus 1, 2, negative 1, 6. So y negative 1, 6, negative 0, 2 plus 1, 2. So this is 0, 32 plus 1, 2, 1, 5, 2. So the answer is 0, negative f of negative 0, 4 approximate to 1, 5, 2. So dy over dx, the second derivative. So this one is 2 minus dy over dx. So in this situation, since we have our analysis for the graph shape was on this slope field. So on the left side, which is when x equals smaller than 0, like between 0 to negative 1 at least, it seems dy over dx looks negative. So it seems the dy over dx value in the interval negative 1, 0 is negative from the solution curve on the slope field. Therefore, look at, yeah. Okay, anyway. So on slope field is slope field. Therefore, that is second derivative could be positive, which means the solution may be the concave up in this interval. That means the approximation from the Euler method would be like this, underestimated. So this is how we can guess. And number 7. This is the f of x. Okay, so there are two graphs, bounded area, not bounded, but we also have this y-axis. So now enclosed area, which is all. So area of all. So we need to find this coordinate from the graph when you draw the graph, you can find, like you can analyze or calc the intersection. What I found 1.9404 comma 1,455. So this is the integral area should be calculated. Like the area between two curves should be calculated with subtraction from the upper part to the lower part. So for x minus x cubed plus 1 minus 3 over 4x dx from 0 to 1,9404. So when we calculate it, the answer is 4.515. And number B, area of R and volume of R. This is the volume of revolution. So pi y squared. We need to integrate pi y squared about the x-axis. If it is about the y-axis, pi x squared dy. So now pi, when we rotate it, we will rotate this the farther one, which makes the larger volume, and we subtract the smaller volume because it makes the whole. So from 0 to 1.9404 for x minus x cubed plus 1 squared, which is y squared, minus 3x over 4 squared dx. So this is larger volume we make like this, and we carve it out from here. So when we calculate it, the answer is 57.463. Number C, perimeter of R. So not integral. So perimeter, we can start from here. 1, 2, 3. So 1 is because it is not difficult to see this y-intercept from the graph, 0, 0 and 0, 1. So that is 1. Plus number 2, we can find the arc length from here too, but since it is the straight line and we already know the coordinates, so we can find the difference, like the distance between 2 points from this Pythagorean theorem. So now 1.9404 squared plus 1,455 squared plus the last 3. This should be from the arc length formula. 1 plus 4 minus 3x squared dx 0 to 1.9404. That's the one. So this is perimeter of R. Number 8, domain 0 to 10, and enclosed area is 10 and 27, length 11 and 18, and this is 3 and this is 8. This is what it described. Average value of f 0 to 5 is 5 minus 0, integral 0 to 5 f of x dx 1 over 5 times negative 10, which is negative 2. So 3 0 to 10 f of x dx plus 2x 0 to 10. So 0 to 10 f of x is negative 10 plus 27 times 3 plus 20. So 5171. And number C, 5 to x, concave up or and decreasing. So g prime of x is f of x. G double prime of x equals f prime of x. So this should be smaller than 0, which is decreasing. Concave up, this is should be larger than 0. So f of x is smaller than 0 in 0 to 5. F prime of x larger than 0 in 3 to 8. Therefore, x should be between, like, intersection of these two interval, which is 3 to 5. Number D, defined h of x. Okay, so 0 to 20 square root 1 plus h prime of x squared dx. 0 to 20 f prime x over 2 squared of dx. So let x over 2 u, then dx over 2 is du. And interval, when x is 20, u is 10, 0. 1 plus u squared, no, I mean f prime u. F prime u squared 2 du. So this is 2 times 9, which is 58. Because this was 11 and this was 18. And number 1. Tony and Brian. Now they consist like this. Okay. So this is e to the power of x over 2. And okay. This is a semicircle. So longer path, Brian or Tony? Brian. Let's calculate for Brian first. So from 0 to 2, square root 1 plus f prime of x equals 1 over 2 e to the power of x over 2. So 1 over 2 e to the power of x over 2 squared dx plus 2 to 5, 3 plus, so this one is 2 comma e, this is 5 comma e, so this height is e plus, so this is 5 plus 1. So when I calculate the first integration from 0 to 2, square root 1 plus e to the power of x over 4 dx. Two comma 66 plus 9 plus e. So 14.38082. And Tony. 2 plus, this is a semicircle circumference and radius is 1. So 2 pi r over 2, which is pi r, which is pi, plus this is 1 and 2, which by the Pythagorean theorem, which is square root of 5 plus 5 plus 2. So when we add them together, pi plus square root of 5 plus 9, 14.37766. Therefore, Brian has took the longer path. Then Tony, whose path creates the region with the largest area. Oh, so the Brian, so let's say this is the path, like perimeter and area for Brian. integral 0 to 2 e to the power of x over 2 dx plus, oh, this is just rectangle, so we can add it 3 times e, 3e. So let's calculate it. 0 to 2 n e to the power of x over 2 n dx plus 3e. So this makes 11.59141. So area of Tony is, let me calculate it like this way. So I'll make the area of this trapezium and subtract this semicircle. So 4 plus 5 times 2 over 2 minus pi r squared half. So pi over 2. So 9 minus pi over 2 makes it 7.42920. So therefore Brian's path created the larger area. Create the region with larger area. So Brian walked more and also create actually quite much larger area. And 2020 BC2 continuous at 1. So when we put 1, g of 1, x goes to 1 minus, this is 1, 2, minus is on the left side, a sine x squared minus 1 makes it sine 0, 0. X goes to 1 plus, x 1 plus ln 1, which is 0. And so this makes a limit x goes to 1, g of x equals 0. So limit exists to 0. And also we need to compare with the function value g1, which is here, the upper part. A sine 0, 0 as limit x goes to 1, g of x equals to g1. Therefore, g of x is continuous at x equals 1. Number B, value of a guarantees differentiable. So g prime of x, a sine 2x 2ax cos x squared minus 1 when x between like smaller than 0 to 0. Equal is not guarantees anything here. And this is 1 over x when x is larger than 1. So limit x goes to 1 minus g prime of x is 2a. And limit x goes to 1 plus g prime of x is 1. 2a should be 1. A equals 1 over 2. Number C, arc length of gx from 0 to 3. So integral 0 to 1, square root of 1 plus, I already found the derivatives there. So a equals 1 over 2, so x cos x squared minus 1 squared of dx plus 1 to 3 square root of 1 plus 1 over x squared of dx. That's it. Number 3, differential equation, continuous and differentiable, 0 to 2. So show that satisfy the differential equation. Arc length of the curve, 0 to 2, 1 plus f prime of x dx equals to the area bounded from 0 to 2 f of x dx. So since this and this are equal, so we can say 1 plus f prime of x can be f of x dx. So let's square them together. 1 plus y f prime of x becomes f square root of x. So f of x is y, so 1 plus y becomes y squared. Y prime. That's why y squared minus y prime minus 1 is 0. Oh, sorry, this is squared because of the arc length. And b, one such functions, g of x is like this. So find the arc length of g of x is 0 to 2. So here, 0 to 2 square root 1 plus g prime of x squared of dx. But this is difficult to calculate because in the square root, and we have this squares like prime square. No, actually it's not very difficult. But anyway, we already know the easier way from 0 to 2, g of x dx. Because of its area, so we need to apply this modulus sign there. But g of e of x and e of negative of x is always positive, which means gx is always positive. So we don't need any modulus sign there. So from 0 to 2, half of e of x plus e of negative x dx. So e of x minus e of negative x, 0 to 2, half e to the power of 2 minus e to the power of negative 2. And when I put 0, this is 1 minus 1, so that is 0. So this is the one. That is the arc length. Portion of the graph is from A to B. It seems like this. So f prime of 0, so f prime x squared is 4 cos 2x squared. So f of g of x, g prime of x seems plus minus 2 cos 2x. But because here it seems from A to B, it seems increasing here in this interval. For this interval, because g prime of x looks positive, yeah, but actually we are not sure about A to B. Yeah, because A and B doesn't show what it is, so we're not. Yeah, this is a little bit vague question, and let's just make it g prime 0 can be plus minus 2. So integral g of x dx. So g of x is plus minus 2 cos 2x. This is the, so sine 2x plus c. This is g of x. So integral dx. So plus minus, yeah, it may to change minus plus, but it doesn't mean anything here. Cos 2x plus cx plus d. So integral g of x dx maybe plus minus cos 2x over 2 plus cx plus d. And equation of the line tangent. At this moment, we think g of x is plus minus sine 2x plus c. So g pi over 2 means plus minus square root 3 over 2 plus c. Oh, I mean pi over 6. And g prime pi over 6 becomes 2 plus minus cos 1. Cos pi over 3. Yep, 1. So therefore y equals 1 x minus pi over 6 plus square root 3 over 2 plus c, or y negative x minus pi over 6 minus square root 3 over 2 plus c. Number 20, BC5. Twice the differential function, differentiable double prime 0 was negative. Okay. Left Riemann sum with the 4 subinterval arc length 0 to 8. So 0 to 8 square root 1 plus f prime of x squared dx. So we can use these subintervals, 4 subintervals, and left Riemann sum. So first interval 0 to 1, 1 to 4, 4 to 6, 6 to 8. This interval, the size 1, 2, 2, 2 is dx, the change of x. So change of x is 1. Square root 1 plus, because it's left Riemann sum, f prime of 0 squared plus, and all this sum makes applying, like implying this integral. So this is 1 and this is 1, 2, 4, 3. This is 2. This is 2. 1 plus f prime 1 squared. 1 plus f prime 4 squared. 1 plus f prime 6 squared. So square root 9, which is 3 times 1. Square root 4, 2 times 3. Square root 1 times 2. Square root 4 times 2. So 3, 6, 2, 4, 15. Euler's method, S8. We need to guess S of 8. So here, 0 to 2 steps 4 to 8. So 0 when x equals 0, y also 0. I mean here S of x, this is x. And let me make the slope here. So S prime of x is a square root of 1 plus f prime x squared. So when we put 0, it's a square root 8 again, and 8, and this is 3. So y is 3 x minus 4, no, I mean step size, which is 4. 3 times 4 plus 0. So this is 12. So yeah, this is not slope. So and in this case, the slope is when x equals 4, f prime of x is 0, so slope is 1. So y is 1 times 4 plus 12 and makes it 16. Therefore, S8 seems 16.